Today we are going to discuss about alcohols. Alcohols are the hydroxy derivatives of alkenes, and these are the compounds in which a hydroxyl group is attached to a saturated carbon atom or alkyl carbon atom. Hydroxyl group means OH. So this OH group is directly attached to the saturated carbon atom, and the general formula of alcohol is ROH. So hydroxyl group and alkyl group. Next, classification of alcohols. Alcohols are mainly classified into four classes: monohydric alcohols, dihydric alcohols, trihydric alcohols, and polyhydric alcohols. Mono, di, tri, and polyhydric alcohols. So alcohols containing only one hydroxyl group. Alcohols containing only one hydroxyl group are called as monohydric alcohols. Then the alcohols containing two, then three, or more than three hydroxyl groups, 2OH, 3OH, and more than 3OH or hydroxyl groups are known as the dihydric, trihydric, and polyhydric alcohols respectively. Monohydric alcohols, for example, CH3OH, that is methanol, CS3CH2OH means ethanol. So these are the two examples of monohydric alcohols. Monohydric alcohols means in which one hydroxy group is attached with the saturated carbon atom, and they may be represented like this. The general formula of alcohol are OH, and these are the examples of monohydric alcohols: methanol and ethanol. Now, these monohydric alcohols are further classified as primary, secondary, or tertiary depending upon whether the OH group is attached to a primary or secondary or to a tertiary carbon atom. So what does it mean? Primary carbon atom, secondary carbon atom, and tertiary carbon atom. So for example, here this is an example of primary alcohol. Next, this is an example of secondary alcohol, and next, tertiary alcohol. So here, OH group is attached to a primary carbon atom. Here, OH group is attached to secondary carbon atom, and OH group is attached to tertiary carbon atom. So primary carbon atom, then secondary carbon atom, and tertiary carbon atom. Primary carbon atom means here this carbon is attached to only one alkyl group, and hence this is called as primary carbon atom. Now here two alkyl groups are present, so this carbon is called as secondary carbon atom. Here three alkyl groups are present, and hence this carbon is considered as tertiary carbon atom. So in the first example, OH group is attached to primary carbon atom, hence it's called as primary alcohol. In this, OH is attached to secondary carbon atom, hence this is called as secondary alcohol. Here, OH group is attached to the tertiary carbon atom, and hence this is called as tertiary alcohol. So this is all about the monohydric alcohols. Further, they are classified into three types again: primary, secondary, and tertiary alcohol. Next type is dihydric alcohol. Dihydric alcohols. Dihydric alcohol means in which two hydroxy groups are attached. Or dihydric alcohol means two hydroxy groups are present. For example, CH2OH and again CH2OH. So the name of this compound is ethylene glycol. So this is dihydric alcohol. Next, trihydric alcohols. Trihydric alcohol means in which three hydroxy groups are attached to carbons. Trihydric alcohols means in which three hydroxyl groups are present. For example, CH2OH, then CHOH and CH2OH. And the name of this compound is glycerol. So glycerol is an example of trihydric alcohol. And last type, polyhydric alcohols. Polyhydric alcohols means in which the many hydroxyl groups are present. For example, CH2 by N, OH, etc. Or the examples of polyhydric alcohols are the sorbitol and mannitol. So sorbitol and mannitols are the examples of polyhydric alcohols. So alcohols are classified as monohydric alcohols, then dihydric alcohols, trihydric alcohols. Monohydric 1OH, dihydric 2OH, and trihydric 3OH. Example of monohydric alcohol is methanol, then dihydric alcohol is ethylene glycol, and trihydric alcohol is glycerol. Example of monohydric alcohol is methanol, and methanol is also called as carbinol. And again, monohydric alcohols are classified into three types: primary, secondary, and tertiary alcohols, respectively. Nomenclature of alcohols. Alcohols are named by three systems: common system, Carbinol system, and IUPAC system. Common system. In this system, alcohols are named as alkyl alcohols. Alkyl alcohols. The alkyl group attached to the OH group is named, and alcohol is added as a separate word. For example, methyl alcohol. Here OH group is attached to methyl. So methyl alcohol, ethyl alcohol, N-propyl alcohol, and isopropyl alcohol. As we go higher in the series, it becomes necessary to indicate whether a particular alcohol is primary, secondary, or tertiary, and the prefix secondary is abbreviated like this, sec, and the prefix tertiary is abbreviated as tertiary, ter. So N-butyl alcohol, normal chain, then secondary butyl alcohol, because this is the secondary carbon atom attached to two different alkyl groups, and tertiary butyl alcohol because here OH is attached to the tertiary carbon atom. Because why this is called as tertiary? Because this carbon atom is having three alkyl groups. So tertiary carbon atom, and the name of this compound is tertiary butyl alcohol. Carbinol system. So in this system, alcohols are considered as derivatives of methyl alcohol, and methyl alcohol is also called as carbinol. So this is methanol or methyl alcohol, and methyl alcohol is also called as carbinol. And All alcohols are considered as derivatives of carbonyl. Say for example, if two hydrogens from methanol is replaced by two methyl groups, then the compound becomes dimethyl carbinol. This is an isopropyl alcohol. Then here two hydrogens from methanol replaced by methyl as well as ethyl. So its name is ethyl methyl carbinol. So in some cases, the alkyl groups attached to the carbon carrying the OH group are named in the alphabetic order, and then the suffix carbinol is added. For example, ethyl methyl carbinol. IUPAC system. In this system, alcohols are named as alkanols. Alkanols. For example, methanol, then ethanol, 1-propanol, and 3-butanol or butan-2-ol. So here we have to follow the IUPAC rules. That is, select the longest continuous carbon chain containing the OH group. Select longest continuous carbon chain containing the OH group. Then change the number of the alkane corresponding to this chain by dropping the ending E and adding the suffix "ol". Number the chain so as to give the carbon carrying the OH group the lowest possible number, and the position of the OH group is indicated by this number. Methods of preparation of alcohols. So these are the some methods by which you can prepare alcohols. Hydrolysis of alkyl halides, hydration of alkenes, hydrolysis of esters, catalytic hydrogenation of aldehydes and ketones. You can prepare alcohols from Grignard reagent and reduction of carbonyl compounds. Hydrolysis of alkyl halides. Alkyl halides react with aqueous sodium hydroxide to form alcohols. And this is the simple nucleophilic substitution reaction. So alkyl halide RX reacts with sodium hydroxide and gives alcohol as well as sodium halide NaX. So ROH and NaX. So here you will get alcohol. Then, so this is the general reaction scheme. What will happen when ethyl bromide reacts with sodium hydroxide? So ethyl bromide gives ethyl alcohol and NaBr. Second method is hydration of alkenes. Alkenes react with sulfuric acid to produce alkyl hydrogen sulfates, which upon hydrolysis gives alcohol. So for example, propylene when react with sulfuric acid gives isopropyl hydrogen sulfate, and this newly formed moiety isopropyl hydrogen sulfate undergoes hydrolysis and it gives final alcohol, that is isopropyl alcohol. So simply Markovnikov rule is followed here. Next method is hydrolysis of ester. Alcohols may be prepared by the acid or base catalyzed hydrolysis of esters. For example, methyl acetate undergoes acidic hydrolysis and gives methyl alcohol and acetic acid as a byproduct. Next method is catalytic hydrogenation of aldehydes as well as ketones. So both are the carbonyl compounds. Aldehydes and ketones can be reduced with hydrogen in presence of nickel as a catalyst or aluminum hydride as a catalyst to form the corresponding alcohols. And Here aldehyde gives primary alcohols and ketone gives secondary alcohol. So aldehyde, when undergoes hydrogenation in presence of the nickel, you will get ethanol, ethyl alcohol. And when ketone, for example acetone, undergoes hydrogenation, gives isopropyl alcohol. So when aldehydes undergoes hydrogenation, it gives primary alcohol. And when ketone undergoes hydrogenation, it gives secondary alcohols. So ethanol is an example of primary alcohol and isopropyl alcohol is an example of secondary alcohol. Next method is preparation of alcohol from Grignard reagent, that is simply the addition of Grignard reagent to aldehyde or aldehyde as well as ketone. So Grignard reagent reacts with aldehyde or ketone to form the additional product, which on hydrolysis with dilute acid gives corresponding alcohol. So before going to discuss the addition of Grignard reagent to aldehyde and ketone, what is Grignard reagent? Grignard reagent means RMGX. RMGX. This is the Grignard reagent. So Grignard reagent reacts with aldehyde. Grignard reagent reacts with aldehyde or ketone to form an additional product. This is an additional product, which on hydrolysis with dilute acid gives the corresponding alcohol. Similarly, ketone reacts with Grignard reagent RMGX, gives additional product which undergoes hydrolysis and gives corresponding alcohol. So when aldehyde react with Grignard reagent, you will get secondary alcohol, and when ketone reacts with Grignard reagent, you will get tertiary alcohol. So this is Grignard reagent RMGX. So RMGX. The alkyl part of the Grignard reagent is delta negative and gets added to the electropositive carbonyl carbon. This one. Electropositive carbonyl carbon, this one. While the MgX part of the Grignard reagent is the delta positive and it gets added to the carbonyl oxygen of aldehydes as well as ketones. Next method is reduction of carbonyl compounds. Acetone in the presence of sodium borohydride, it gives alcohol. For example, propan-2-one, that is acetone, gives propan-2-ol. Then physical properties. Common alcohols are liquid at room temperature, high boiling point as compared to alkanes, and lower alcohols are soluble in water. So, why alcohols are having higher boiling points than alkanes? So the OH bond of the alcohol, this one, the OH bond of the alcohol is highly polar because of the oxygen. The oxygen carries a partial negative charge and the hydrogen carries a partial positive charge. The polarity of the OH bond gives rise to the forces of attraction between the partially positive hydrogen of one alcohol molecule and the partially negative oxygen in another alcohol molecule, and these forces of attraction are referred to as hydrogen bonding. The reason that alcohols are having higher boiling points is a large amount of energy is utilized. A large amount of energy in the form of heat is utilized or is required to overcome these attractive forces or required to break the hydrogen bonding. So, alkanes which have no OH group do not undergo hydrogen bonding and therefore their boiling points are low as compared to alcohols. So this is the reason why alcohols are having higher boiling points than alkanes. Next, why lower alcohols are soluble in water? So same reason. A compound that forms the hydrogen bond between its own molecule can also form the hydrogen bonding with the water molecule. And this alcohol water hydrogen bonds are the cause of high solubility of lower alcohols in water. So in higher alcohols, the non-polar alkyl group becomes more important. They have lesser tendencies to form hydrogen bonds with water and hence they are less soluble. Chemical properties or reactions of alcohols. So these are the some important chemical reactions of alcohols. Reaction with the active metals, reaction with hydrogen halide, reaction with thionyl chloride, reaction with carboxylic acid, reaction with acid halide, and dehydration of alcohols to alkenes. First important reaction with active metals. So alcohols react with sodium or potassium to form the alkoxides with the liberation of hydrogen gas. This reaction shows that alcohols are acidic in nature. Ethanol reacts with sodium, gives sodium methoxide. So this reaction shows that alcohols are acidic in nature. The reason for this is that the OH bond in the alcohols is polar and allows the release of the hydrogen atom as a proton. However, alcohols are weaker acids than water. This is because the alkyl groups in alcohols exerts a positive inductive effect and they release electrons towards the oxygen atom so that it becomes negatively charged, and this negative charge on oxygen makes the release of the positive proton more difficult. So as we had already discussed about the classification of alcohols, they are classified into primary, secondary, and tertiary alcohols. So, which one is more acidic? Whether primary alcohols or secondary alcohols or tertiary alcohols is more acidic? Which one is more acidic? So, primary alcohol, secondary alcohol, and tertiary alcohol. So, the tertiary alcohols, tertiary alcohols are less acidic than the secondary alcohols as well as primary alcohols. Tertiary alcohols are less acidic than secondary alcohols, whereas the secondary alcohols are less acidic than primary alcohols. This is because of the positive inductive effect of alkyl groups. The positive effect would be maximum. The positive inductive effect is maximum in case of tertiary alcohols as they contains the three alkyl groups attached to the carbon bearing the OH group, and hence primary alcohols are more acidic than secondary alcohols than tertiary alcohols. So sodium metal reacts vigorously with alcohols such as methyl alcohol or ethyl alcohol with the evolution of hydrogen gas seen as bubbles. Methyl alcohol has proved to be excellent fuel for racing cars. Alcohols are not acidic enough to react with aqueous NaOH or KOH. Means ROH plus NaOH, no reaction. They are not acidic enough to react with aqueous NaOH or KOH. Next reaction is reaction with hydrogen halide, that is HX. So HX means, what is HX? HX means HCl, HBr or HI. So alcohols react with HX, that is hydrogen halide, and it gives alkyl halide. The final product is alkyl halide. So when alcohol reacts with HX, that is hydrogen halide, it gives alkyl halides and water. ROH, alcohol plus HX gives alkyl halide plus water. What will happen when methanol reacts with HCl? So CH3OH methanol react with HCl gives methyl chloride plus water. So if you observe, HX means HCl, hydrochloric acid, HBr and HI. So no catalyst is required in case of HBr and HI. No catalyst. No catalyst is required in case of HI and HBr, and HCl reacts in presence of a catalyst, that is anhydrous zinc chloride. Reaction mechanism. So step 1 is protonation of ethyl alcohol, CH3CH2OH. The hydrogen comes from HX, that is hydrogen halide. After protonation of alcohol, we'll get new product, that is protonated alcohol or protonated ethanol. And in step 2, the nucleophile bromine attacks the carbon holding the protonated hydroxyl group to form the ethyl bromide, and the byproduct is water. Reaction with thionyl chloride. Alcohols react with thionyl chloride, that is SOCl2, and it gives ethyl chloride with the liberation of SO2 and HCl. Reaction with carboxylic acid. Alcohols react with carboxylic acid to form ester. For example, ethanol, when react with acetic acid, it gives ethyl acetate. So the reaction between alcohols and carboxylic acid to form the ester is called as esterification. When acid react with alcohol, it gives ester, and the reaction is called as esterification. So here the concentrated sulfuric acid is used, H2SO4. H plus comes from H2SO4. The concentrated sulfuric acid is used as a catalyst, and the reaction is reversible and can be shifted in the forward direction by removing the water as soon as it is formed. So H2SO4 is the good dehydrating agent which absorbs the moisture from the reaction and makes reversible reaction to irreversible. Reaction with acid halide. So in this reaction, acetyl chloride reacts with ethyl alcohol and gives ethyl acetate. So when acid halides, this is an example of acid halide. Acetyl chloride is an example of acid halide. When acid halides reacts with ethanol, ethyl alcohol gives ester ethyl acetate. Dehydration of alcohols to alkenes. When ethyl alcohol is treated with concentrated sulfuric acid at 170 degrees Celsius, ethylene is formed. Notice that only one alcohol molecule is involved in this reaction. What about the dehydration of secondary and tertiary alcohols? So dehydration of secondary and tertiary alcohols containing 4 or more carbon atoms gives a mixture of two alkenes. So the alkenes produced in greater abundance is indicated by Sitzeff rule. So here 2-butanol when react with concentrated H2SO4 at 170 degrees Celsius, you'll get two products, 1 butene and 2 butene. But here 2-butene is the major product because the alkene produced in the greater abundance is indicated by the Sitzeff rule, and Sitzeff rule states that the alkene formed preferentially is the one containing the higher number of alkyl groups. Reaction mechanism, step 1 is protonation of alcohol molecule. So after protonation of ethyl alcohol, the product is protonated alcohol. Step 2 is elimination of water molecule from the protonated alcohol, and it gives a stable carbonium ion. Then step 3, carbonium ion loses a proton to give the alkene. Some important qualitative tests of alcohol. These are the some important qualitative tests of alcohol. Oxidative test, also called as Dichromate test, Catalytic Dehydrogenation, Victor Meyer's method, and Lucas test. All these tests are used to distinguish between primary, secondary, and tertiary alcohols. So first test is oxidative test or oxidation or dichromate test. Can we oxidize alcohols? So answer is yes. We can. Alcohols can be oxidized, and the nature of the product depends on the type of alcohols and the conditions of the reaction. So as this is the oxidation reaction, we want some oxidizing agents. So the most widely used oxidizing agents are KMnO4 plus H2SO4, potassium permanganate plus H2SO4, then sodium dichromate plus H2SO4, and potassium dichromate and H2SO4. So these are the most widely used oxidizing agent for this reaction. So oxidation of alcohols, this test is used to distinguish between primary, secondary, and tertiary alcohols. So draw the structures of primary alcohol, general structure of primary alcohol, secondary alcohol, and tertiary alcohol. Oxidation in presence of oxidizing agents like KMnO4 plus H2SO4, Na2Cr2O7 and H2SO4, or potassium dichromate and H2SO4. So primary alcohols are first oxidized to aldehydes, and then on further oxidation, aldehyde gives carboxylic acid. Notice that the acid and alcohol contains the same number of carbon atoms, and the reaction can be stopped at the aldehyde stage by removing it from the oxidizing medium as and when it forms. Secondary alcohols are oxidized to the corresponding ketones, and tertiary alcohols are stable to oxidation under normal conditions, means there is no reaction. So on oxidation, primary alcohol gives aldehydes. On oxidation of secondary alcohol gives ketone. On oxidation of tertiary alcohol, you will not get any product. So CH3CH2OH, ethanol, example of primary alcohol, then 2-propanol, secondary alcohol, and last one is tertiary alcohol. So this test is based on the fact that different types of alcohols gives different products on oxidation. The alcohol is treated at room temperature with sodium dichromate in sulfuric acid. So initial, the color of this reaction mixture is orange. Identification of the product gives the information regarding the types of alcohol. Primary alcohols gives a carboxylic acid containing the same number of carbons, and there will be a change in color of the solution from orange to green. Secondary alcohol gives a ketone containing the same number of carbons, and there will be a change in the color of the solution from orange to green. And tertiary alcohols do not react under these conditions. The solution will remain orange. Next qualitative test is catalytic dehydrogenation. So different types of alcohols gives different products when their vapors are passed over the copper gauze at 300 degrees Celsius. For example, ethyl alcohol when react with copper at 300 degrees Celsius, you will get acetaldehyde. And when 2-propanol react with copper, you will get acetone. And when tertiary butyl alcohol reacts with copper, you will get 2-methyl propene. So on catalytic dehydrogenation, primary alcohols primary alcohols loses hydrogen and gives aldehyde. Secondary alcohols loses hydrogen and gives ketone. And what about tertiary alcohol? Tertiary alcohols are not dehydrogenated but loses a water molecule and gives alkene, that is 2-methyl propane. Next test, Victor Meyer's method. In Victor Meyer's method or Victor Meyer's test, alcohol is first treated with phosphorus and iodine to get iodoalkanes, which is then treated with AgNO2, silver nitride, to get nitroalkane. The nitroalkane thus obtained is treated with the nitrous acid. And nitrous acid is nothing but the mixture of NaNO2, sodium nitrite, and HCl. The nitroalkane thus obtained is treated with nitrous acid, and the resulting solution is finally made alkaline with KOH, and you will get some color. So primary alcohol gives red color, secondary alcohol gives blue color, and tertiary alcohol gives no color with KOH. So in this test, various alcohol are first treated with iodine to convert it into the corresponding iodide, that is iodoalkanes. Then this newly formed moiety is treated with AgNO2, that is silver nitride, to get the corresponding nitroalkanes or nitroparaffins. Then thus nitroalkanes are finally treated with nitrous acid and then made alkaline so primary alcohol gives red color, secondary alcohol gives blue color, and tertiary alcohol that gives no color. This reaction is not possible with this tertiary alcohols. So don't be confused on the third step, that is reduction of nitroalkane with HNO2 nitrous acid. Just try to remove water molecule as a byproduct. So you will get nitrolic acid, secondary alcohol gives pseudonitrile, and reaction is not possible with the tertiary alcohols because carbon atom has no replaceable hydrogens. Lucas test. In this test, alcohols are treated with a solution of HCl and zinc chloride, and this mixture of hydrochloric acid and zinc chloride is called as Lucas reagent. Lucas reagent means it is a mixture of HCl and zinc chloride. So when alcohols are treated with this solution or alcohols are treated with Lucas reagent, it gives alkyl halides and zinc chloride is serves as a catalyst. So the three types of alcohols undergoes this reaction at the different rates. Tertiary alcohols reacts with Lucas reagent very rapidly. Secondary alcohols react somewhat slower, and primary alcohols react with Lucas reagent even more slowly only at high temperatures. So the reactivity of alcohols, tertiary alcohol is greater than secondary alcohol is greater than primary alcohol. So initially alcohol is mixed with concentrated HCl and zinc chloride. So the alkyl chloride which is formed is insoluble in the medium. It causes the solution to become cloudy before it separates as distinct layer. With the tertiary alcohol, cloudiness appears immediately. With secondary alcohol, cloudiness appears in 5 minutes, and with primary alcohols, the solution remains clear. This is because primary alcohols do not react with Lucas reagent at room temperature. High temperature is required for primary alcohols. Here CH3 CH2OH, that is ethanol, example of primary alcohol, react with zinc chloride and HCl, that is Lucas reagent. No reaction because reaction takes place after heating only. Secondary alcohol, for example propanol, react with Lucas reagent, zinc chloride and HCl, gives 2-chloropropane, and the reaction takes place within 3 to 5 minutes. Then tertiary alcohol, that is 2-methyl propanol, react with Lucas reagent, gives 2-chloro 2-methyl propane, and the reaction takes place immediately. So this is the positive Lucas test and negative Lucas test. So how to distinguish between primary, secondary and tertiary alcohols? So few tests are used to distinguish between primary, secondary and tertiary alcohols, like oxidative test, catalytic dehydrogenation, Victor-Mears test, and Lucas test. Ethyl alcohol. So this is the structural formula of ethyl alcohol. C2H5OH. So this is structural formula and molecular formula. Alcohols or ethyl alcohol is the alcohol of wine, beer, whiskey, and similar beverage. It is often referred to as simply alcohol. Ethyl alcohol is also known as grain alcohol since it can be prepared from starchy grains. It is colorless, volatile liquid with a characteristic pleasant in odor. Boiling point is 78 degrees Celsius, miscible in water, and flammable liquid. It is used as antiseptic and disinfectant. It is used in the manufacturing of alcoholic beverages. It is used as an antidote against methanol and ethylene glycol poisoning. Medically, it is used to depress the CNS. It is used in the manufacturing of drugs and perfumes. It is an industrial solvent used in the formation of chemical and paints. It is used in the manufacturing of synthetic rubber, used as hand sanitizer, as an industrial solvent in the manufacturing of drugs, flavoring extracts and perfumes, as a preservative in biological specimens, in the manufacturing of acetaldehyde, acetic acid, ethyl chloride, and ethyl acetate. Roadside breath test, a novel application of the oxidation of ethyl alcohol is found in the roadside breath test, a screening device intended to give a rough measure of the quantity of alcohol in the blood. It is based on the premise that the ethanol absorbs into the blood from the stomach and intestine and is continuously transferred into the lungs and get exhaled. So simply, this operation, the operation of the breath analyzer used in the test is based on the potassium dichromate sulfuric acid oxidation of ethanol. The particles of the silica gel in sealed glass ampule are impregnated with the reagents before the ampule is used. The ends are broken off, then one end is fitted with the plastic mouthpiece and the other is attached to the neck of the flattened bag. When air containing ethanol is blown through the tube, a chemical reaction takes place and the chromium sulfate produced is shown by the formation of green color in place of the original orange reagent. If the green color extends beyond the yellow center mark of the tube, the motorist is considered drunk and taken to the police station for further test. Alcohol industry. A solution of glucose in water remains unchanged indefinitely. If, however, to this solution some yeast is added, after some time the whole liquid begins to froth and looks like a boiling. On testing, it is found that glucose has been converted to ethyl alcohol, and the boiling appearance is in fact due to the brisk evolution of the carbon dioxide during the reaction. Absolute ethanol. Absolute ethyl alcohol is 100% pure ethyl alcohol. Commercial alcohol is a mixture of 95% ethyl alcohol and 5% water. The mixture cannot be separated by further distillation, and such a solution is called as azeotropic mixture or azeotrope. Then denatured alcohol. Denatured alcohol is commercial ethyl alcohol to which small amounts of very poisonous substances have been added. The manufacture and sale of ethyl alcohol is under the strict government control. Heavy excise, Heavy excise duty is levied on sale of alcoholic beverages. For industrial purpose, ethyl alcohol is duty-free and therefore the commercial alcohol is denatured by the addition of poisonous substances like methyl alcohol or pyridine. Methyl alcohol, CH3OH, it is colorless liquid and its boiling point is 64 degrees Celsius. It is miscible in water and poisonous when taken orally. As little as 30 ml can cause death and lesser amounts can cause irreversible blindness. It is used in the manufacturing of formaldehyde, used as solvent, and in the manufacturing of paint. Methyl alcohol is also known as wood alcohol because it was formerly obtained by the destructive distillation of the wood. A mixture of methanol vapor and air is easily ignited by even a small spark. It is used to denature the ethanol and also used as motor fuel. A 20% mixture of methanol and gasoline makes a good motor fuel. Chlorobutanol, it is colorless or white crystalline powder with characteristic odor, slightly soluble in water but freely soluble in chloroform. It is used as preservative in many pharmaceutical and cosmetic products. It has antibacterial and antifungal activity. It has sedative, hypnotic, and local anesthetic activity, gives relief from pain, used in gargle solutions, and used to treat mouth ulceration, also used to treat the throat infection. Cetostearyl alcohol. Cetostearyl alcohol is a mixture of fatty alcohols consisting predominantly. Cetyl alcohol contains total 16 carbon and stearyl alcohol contains total 18 carbons and is classified as a fatty alcohol. It is a white solid material in the form of flakes, not soluble in water but soluble in oil, used as an emulsion stabilizer, also used as opacifying agent and foam boosting surfactant, as well as an aqueous and non-aqueous viscosity increasing agent commonly used in the hair conditioners and other hair products. Benzyl alcohol, it is also called as phenyl methanol or phenyl carbinol. It is an aromatic alcohol, colorless liquid with a mild pleasant aromatic odor. It is soluble in diethyl ether, also called as local anesthetic. It is used as the general solvent for inks, paints, and liquors. It is used in hair dyes. It is produced by many plants and commonly found in fruits. Used as bacteriostatic and preservative, having antibacterial and antifungal activity. Then it is used in the preparation of soap and perfumes and has insect repellent properties. Glycerol, it is also called as glycerin. It is a trihydroxy sugar alcohol with sweet taste. Viscous at room temperature and non-toxic in low concentration. It is used in cosmetic industry to enhance the texture of lotions and creams. It is used to preserve food and also enhance the viscosity and texture, mainly used as lubricant and humectant, used in the soap preparation. It is used as laxative. It is used to produce nitroglycerin and used to treat the stroke. And the last alcohol, propylene glycol. Propylene glycol, it is tasteless, odorless, colorless, and clear oily liquid that is hygroscopic in nature. It is used as a solvent for food color and flavoring agent, used as a main ingredient in deodorant sticks. It is used in hand sanitizer and antibacterial lotion and also used in the preparation of saline solution. It is synthetic organic compound which is viscous, colorless, odorless, and sweet in taste, used as a solvent and preservative in food, used as solvent for many pharmaceutical preparation, used for production of unsaturated polyester resins, and used in the various items such as coffee based drinks, liquid sweeteners, ice cream, and soda. Thank you.